So yesterday finishes up the Unit 8 material, but we're going to go ahead and get into Unit 9 material today and tomorrow. That way you at least know a little bit about everything before you go into the mock on Thursday. On Friday, what?
Only 9 units.
Only 9 units. On Friday, we will then work on the Unit 8 review and take a test on that next week sometime, and then we'll come back and finish up Unit 9. And then we'll do our review the rest of the time to get us ready for the test.
Does that mean that our test is not necessarily the 31st?
It'll probably be the 31st. What day of the week is that?
Tuesday.
It's not going to be Tuesday. Because I forget. I was when I put that up there, I was forgetting that we're not going to have school on Monday. So it'll more than likely be Wednesday.
What's Monday?
Right?
Yeah.
Alright, so today we're looking at finding area between two curves. And previously when we found area, it's between what and what? When have we found area?
Between the x-axis.
Between the x-axis and the curve. Okay, and what did we do to find the area between the x-axis and the curve? We integrated from our starting point to our finishing point, and then we integrated the curve, and that gave me the area between the curve and the x-axis. Okay? Today, we want to find the area between two different curves, as you see up here. We want to find that shaded area that's between my two curves. So, do you guys have any thoughts on what we can do to go about finding that area?
Integrate.
Integrate?
It's actually a curvy curve. So.
More than that.
The
Be a little
curve.
more specific.
Well, it's like two parabolas, so we would do something like
What'd you say, Brock?
Integrate and find the derivative.
No.
Integrate and plug in.
Integrate what?
Curve.
There's two curves.
Both curves.
What do you mean?
Oh,
integrate?
differential equation.
Integrate the equation of the tangent line, or secant line.
Quit throwing stuff out there. Think. It's not. You guys should be able to come up with it.
You don't do a differential equation with the things where it's
No.
where you get to separate.
Integrate the part of the curve that
Oh, integrate the whole thing between the x-axis
Equation of the shape.
and then subtract the outside part.
All right. Harrison's on the right track there. Okay.
That's
So what we're gonna do is
I use my hands. You didn't see the whole thing.
we are going to integrate from just the top curve all the way to the x-axis. Then we're going to integrate from the bottom curve to the x-axis, and then what are we going to do with those two areas? Okay. We're going to subtract them, and that gets me back to the area that's in between. Okay. So, in order to do that, what is it we need to identify? I can't hear you.
set the equation.
Integrate
What do we need to identify to be able to get my solution?
equation of the line.
Give me any endpoints because that gives me my limits. But what else do I need to identify? What did we just say we were going to do?
Integrate.
Find what first? The top all the way down to the x-axis. Then we're going to find on the bottom all the way down to the x-axis. And then what are we going to do? Subtract. So what do I need to identify first? I need to identify the top function first. Okay? And then what are we going to do with the second one?
Bottom.
What are we going to do with that?
Subtract.
Subtract it. Thank you. That's all we're going to do. We're going to subtract it. So, I do not have to set this up as two different integrals. You know, the first integral is going to give me all the area from top to bottom. The second integral would give me the area from the bottom to the x-axis. And then I would subtract it. But I don't need two separate integrals. All I have to identify is which one's on top, which one's on bottom, and subtract them. And then integrate. Okay, so if I were to set this up, I believe this is an x value of -2, or -1. So we're going from -1 to 1, and then whatever my top function is minus the bottom function, when I integrate that, that gives me the area of the shaded region. So that's how you find the area between two curves. So now jump to your note sheet, and we're going to work these two problems. So on this first one, it says let R be the region bounded by the graphs of y equals the square root of x and y equals x over 2, as shown in the figure above. Find the area of R. So who can set it up for me to find the area of R? Harrison.
Integral 0 to 4 square root of x minus x over 2 dx.
Very good. That integral finds the area of the area of region R.
How do you know which one's the top and bottom?
Great question. How do you know which one's on the top and which one's on the bottom? This one should be fairly easy because what do you know a square root of x looks like?
Straight line.
Half a parabola. You should know from last year pre-calc that square root of x is half a parabola, and you should know x over 2 is a straight line. So it should be pretty easy to identify. But let's say I didn't know that. What's something else I could do to figure out which one's on top? Plug in a point in my interval. So between 0 and 4, I can pick an x value out. Obviously, 1's probably the easiest to plug in. If I plug 1 into the square root, that gives me 1. If I plug 1 into x over 2, that gives me 1/2. Since one of them gave me 1 and the other one gave me 1/2, then the one that gives me a bigger number is the one that's on top. So that tells me the square root of x has to be on top. You guys follow that? Okay. All right, so now let's integrate. What do I get when I integrate the square root of x?
2/3 x to the
Negative
3
1.
halves.
So 2/3 x to the 3/2. What do I get when I integrate x over 2?
1/2 over 2. So I don't know.
X is 30.
X squared over
No, it's just X.
X squared over 4. Why is it over 4? You gotta divide by 2. There's already a 2 down there, so it becomes 4. So now we plug in. Plug in 4. So 2/3. 4 to the 3/2 minus 16 over 4, and then minus, when I plug in 0, I'm going to get 0. At this point, you've got all the points possible, but we're going to go ahead and find the actual answer. So what does 3/2 want to do to 4? Square root it and cube it. So if I square root 4, I get 2. If I cube it, I get 8. 8 times 2 gives me 16/3 minus 4. So what do I end up with there on 16/3 minus 4? 4/3. So what does 4/3 represent? Or the area between those two curves. Now your points, here's where your points come from. You get 1 point for setting it up. You get 1 point for your antiderivatives, and you get 1 more point for plugging in.
So you don't even have to solve
So
it.
we don't have to.
So once you plug in, if it's a free response problem, you can stop
So we don't have to.
In
Is that
anything
how
or
it
just
is on
the
those
on
problems?
free response. Once you
I mean,
integrate
just this kind
and
of problem.
plug in, once you integrate and plug in, you're done. You do not have to do anything else.
What about
Cool.
other free response questions?
Other same thing.
Do we need to put in like units squared or something since it's area? Or
Not if they don't give you any units. All right. Any questions on this one? All right. Next one. So let's let R be the region bounded by the graph of y equals negative x squared plus 4x plus 2 and the graph of y equals x plus 2. Find the area of R.
So using the same graph.
It's not using the same graph. It's something
So
different.
is it not a definite?
It is a definite interval. We need to find the limits. What am I going to do to find the limits?
Factor.
Integrate.
Nope.
Root it.
Potential.
I'll
Flip
set
it.
equals 0.
Flip it. That was your
Set
Graph
them
it.
to each other.
If we go back up
Plug
here. If we go back up here, what made the limits of this first one?
in. Its points.
Were they met?
Where they intersected, correct? So how do I figure out where these two functions intersect?
So equal to each other.
They set them equal to each other and solve is how we find the intersection points, which gives me my limits.
You said everything.
So negative x squared plus 4x plus 2 equals x plus 2. That tells me where these two graphs intersect, which is going to give me my limits. So negative x squared plus 4x plus 2 equals x plus 2. What do you recommend we do next?
Subtract those ones.
Same side. Which side do you want to go to?
The left.
I would go to the right side. Why the right side?
Get a positive x.
That way I want my x squared to be positive. So I'm going to have x squared minus 3x and the 2's cancel. Factor out an x. And at this point we see that our limits are going to be 0 and 3. So 0 to 3. What's the next thing I need to determine?
Plug in the point on top.
Which one's the top function and how do I do that?
Again,
Plug a number in. What do you want to plug in? 1. So if I plug in 1 to this first one, I get negative 1 plus 4 plus 2. So the first one gives me 5. On the second one, if I plug in 1, that gives me 3. So which one's on top? The first one's on top. So negative x squared plus 4x plus 2, and then minus, make sure you put parentheses around your other function, because what has to happen? The negative has to distribute.
can you do minus x minus 2 and then get rid of the 2's and x before you integrate?
That's what we're going to do, yes. We're going to simplify it before we integrate. Logan, what's your question?
Can you plug in 0?
No. Because what do I know about these two functions at 0? They're at the same spot, so that's not going to tell me which one's on top. So 0 to 3, negative x squared plus 3x, and the 2's cancel. So I cleaned it up a little bit. That way I don't have to integrate as much. So negative x squared, what do I get when I integrate? Negative x cubed over 3, and when I integrate 3x? So 3x squared over 2. So now I plug in. So I plug in 3. That's negative 27 over 3, which is negative 9. I plug in 3. That's going to give me 27 over 2. And when I plug in 0, that's going to give me 0. Get a common denominator, so that turns it into 18 over 2. So we end up with 9 halves. What does 9 halves represent? Area between those two curves. So I'm going to get 1 point here. I'm going to get 1 point there. And I'm going to get 1 point there. Or actually, 1 spot up. Now, sometimes when you're doing these, such as I might have worked this and I might have ended up with negative 9 halves as my answer. Does anybody know what that tells you?
You're wrong.
It tells you you're wrong. But what else does it tell you?
You switched, you did that, you subtracted the smaller one first. First.
That is correct. What Harrison is trying to say, he's trying to say I had the wrong function on top. So if this ever happens to you and you're doing area between two curves and you get down to an answer that's negative, what should you do?
Take the negative off.
Flip them.
Take the negative off, that's going to be your answer, but what else should you do? Go back and change it up. So let me show you that that's what's happened. So if I go back in here and I switch the order, I did x plus 2 minus negative x squared plus 4x plus 2 dx. So I'm going to get negative x squared, I'm going to get negative 3x, and the 2 still cancel. Is that right? Positive x squared, there we go. Now is that right? Yes. So I get x cubed over 3 minus 3x squared over 2 from 0 to 3. So I plug the 3 in, that's 27 over 3, which gives me 9. And I plug 3 in here, which gives me the 27 over 2. multiply turns into 18 minus 27, which gives me negative 9 over 2. So if I got to this point and I got a negative, that tells me that I had the order of these two wrong. So I know my answer is going to be 9 halves, but I need to go back and change my order.
So if this is a free response and you did the first part wrong, but you realized that you had the answer wrong and you just put like a positive on it and took the negative off, would you
Yeah.
still do points?
You have to rewrite your whole.
I would rewrite it.
You have to rewrite all your work though, or just the beginning.
I would rewrite this and then change the sign of this, and you should be good to go.
So the answer always positive.
Answer when you do area between two curves should always be positive. All right. So what do we need to make sure of when we're finding area between two curves? What do we need first? We need our limits. And if we can't tell what the limits are, how do we get the limits? Set the functions equal to each other. Then what do we need to determine?
Which one's on top?
Which one's on top, and then all I do is integrate and work it out. Now, if I end up with a negative answer, what does that tell me?
You put it right on top.
I put the wrong one on top, so I need to go back and change it, and my answer should be the positive of what I got.